will say is most organizations, when they go down the path of moving things to cloud, refactoring, any of those things that would be considered transformative or re-engineering, you need to have good outcomes. And in most cases, we don't. So what we've done at Arctiq with GitLab is we've invented a new method for Gitflow. We've invented a new method for the SDLC. And the intent of it is not to achieve that goal yet. It's to set it as a future stretch goal and a target for the business and for each of our clients and customers or anybody in the market to recognize this is an area that I can have that's an outcome that I never thought of before, which will actually justify your business case. And then Scott will take it home with how GitLab does that as well. We do have a short demo that we can show that actually resembles what this will look like. And we're going to walk you through where you are today and how you can get to what we're proposing that has huge sustainability impact to planet Earth. So we'll start there. There's just some statistics that we put together because we don't actually realize how much power is consumed by data centers, but it's vast. So it's essentially a whole % of the global demand. Emissions is also quite high up there total. The environmental impact is actually quite large. Most people haven't made this understanding yet, is that if it uses power and water, draws on the water table, then you have an even larger environmental impact for data centers. And then just contextually, how much do these very large organizations that use these data centers produce of greenhouse gases, right? So top 25 companies, they are also part of a climate responsibility group. The reason being is they account for 5% of the greenhouse gases on planet Earth. And then we basically are trying to find out if they're actually going to fix it themselves. And then based on the data, we found that the circumstances are very clear that no one has high integrity. Very few organizations have a reasonable integrity. Very few have moderate integrity, and almost all of them have low integrity. You'll note that the two cloud providers that are part of the 25 companies that make up 5% of the greenhouse gases, it's not high. So it's not to say that they're doing a bad job. It just means that we need to take part of our responsibilities in our methods and our practices to advance them so that we're not reliant on someone else to save energy, to save on water, to save on things we could be doing to not waste resources. So we're going to show you how and how you get there to actually save a large percentage of your spend in cloud, reduce the environmental impact and footprint of data centers, which inevitably is a double win for your organization and a future outcome of the adoption. I did want to quickly go through what this is from a value perspective. So what we did was we took a little more analysis and we say, okay, so if we spend $700 billion or so on everything cloud, that's private cloud and public cloud, that's today. Well, it's a little dated, it's about 5 or 6 months dated. We found that they didn't analyze what workloads, the cost of workloads in non-production. No one was thinking, what can I do with non-production? It exists. But in our circumstance, we're going to show you how it doesn't exist and it doesn't persist. But technically, it's almost 50%. We analyzed this and then said, if we have the growth that we have today, it's going to have massive impact on the environment because we have an 84% increase of data center consumption over 4 years. Like, it's just, the growth is vast. We basically broke it down and said, if the analysis, which is very clear, Gartner and others have found that non-production is pretty much idle. 3/4 of the time that machines are running, they do nothing in non-production because they're not utilized by our customers and don't provide any value to run. So it's kind of a massive percentage of the almost half of our data center run could be eliminated. At least the idle time could be eliminated if we didn't persist non-production when we're not using it. So how the hell do you do that, right? So we're going to combine two things today. And maybe not everybody's familiar. Everybody probably knows what CICD is to deliver software. Everybody may not be too familiar with what GitOps is. So we're converging the delivery of applications and the delivery of infrastructure as a merge request. So if I'm merging my code from one stage to the next, be it an environment or an SDLC stage, I will add a single step which has fundamental impact to your savings and non-production is, if I build and collect metrics that I require to get confidence for production, why persist the environments? I'll build more resilience if I don't keep them, and I can reduce, drift between environments. So this fundamental step has a huge financial benefit and very good social and environmental impact to planet Earth. Okay, so I'm going to start and walk you through how we get there. And then after that, I'll do a 5-minute demo or shorter than that and hand over to Scott. Everybody has an application. They put it in the cloud. They front end it with a load balancer. That's what we're depicting here. We then make it highly available, right? In the event of a failure, somebody's got to fix it and bring that VM back. Or I can run stateless and it's completely automated. The VM comes back and sorts itself, and automation takes care of it. Again, this is self-healing methodologies that nothing's involved at all. It just, if you lose a machine, it can come back and you're not impacting the service. The services, the users aren't impacted by that loss. Moving forward, we might break it into microservices, maybe still in a VM format. I'm walking everybody through what we're comfortable in are doing today, and it's incremental. You can start from wherever you want, but it is a target path. You can't skip any of these phases. You have to do them. Once you've broken down, you can make it a Docker container and validate that you can run things as container workloads. We'll get to why container workloads are helpful, because they reduce the idle time. In our eyes, a lot of people argue between VMs and containers. The most important fact is, if I can deploy and test my things much more quickly and not wait for an operating system, my idle time can be, well, technically you're increasing your idle time because the time you need to run doesn't take very long to stand it up. So it's to be more effective and efficient with your environments. Manage Kubernetes so you can scale up and down. That actually helps you destroy things, shrink clusters, not maintain what's not needed. So it's scalability. This is the most common direction today, and this is where people stop. I have a pipeline, and that pipeline does some checks at each stage, and it promotes. And it just keeps going through. Apps keep coming through, and it always just validates and creates environments. But they persist. It's just state. What we're proposing is you move towards destroying non-production environments. But again, this isn't sustainable Gitflow. It's still very much pipeline oriented and singular in fashion. You can't go backwards in this because it's an end-to-end pipeline. So we look at things as a singular function, but they're not actually. They can be code-based. And if you follow our sustainable Gitflow, this converges. I know it seems very complex, but all we're doing is including the ability to create on-demand environments as a merge component. And if you fail on a particular stage, you can go back, but not start the entire pipeline over because you're wasting resources again. So for example, let's say you failed something in staging, you just fall back to the staging merge and then run that stage again versus going all the way to the beginning and running your end-to-end pipeline. So it has efficiencies that we'd like to share. I'll stop on talking. If there's any questions, let me know, Scott, and I can take them now before I jump into the demo. Good? Okay. I guess Scott's good.
I think we're good.
Okay.
Yeah.
Let me jump
into the chat, but there's no questions in there yet. So if anyone has any questions, feel free to pop them into the chat, and we'll make sure Scott and Shlomo see them and get your questions answered.
So from our side, what we're sharing right now is when I have a application pipeline that's running, I can also have an independent GitOps pipeline that triggers as part of that process to help and consume infrastructure as part of a merge request. So that's what you're seeing here right now. We have a test application. It can say CICD pipeline. What we're doing here is, we're leveraging, in this case, Terraform in GitLab. This is our GitLab instance that we use. We're going through a process at which we're helping with the deployment of infrastructure in context to an application. And when the application is done, all the testing, we're going to remove that environment. We're not going to persist it. In this case, it's a dev environment. Do not suggest this in any way for production environments or extremely high utilization environments, meaning many people are testing, not testing in it, but you might have customer demo systems. You can't have live customers in it. This is for development processes that only build confidence for production. So if I have a CI/CD pipeline doing apps, integrate the GitOps requirements as part of it. And when you're merging between stages or merging between environments, because you can do either, you will use these types of pipelines and destroy the environments because they're not needed. They're not being utilized. Once I get my metrics and verification and confidence, I then can delete what I'm not utilizing. The impact here is massive. You have huge financial benefits. I'll stop sharing because I'll switch back for you, Scott, so you can switch your own slides. Are you comfortable with that?
Yeah, sure. Go for it.
And this is not something that's just a pipeline thing. You can't use any CI/CD process to do this. It has to be Git-driven CI/CD processes to achieve these goals. So GitLab is well suited to meet our sustainable Gitflow requirements using their DevOps platform. It's not achievable in many of the CI/CD products out there today. So please understand the environmental impact and financial impact of taking this as a stretch goal and work towards this as much better than continuous deployment. It's, I guess, sustainable continuous deployment. And with that, I hand over to the brilliant Scott, who will walk you through how GitLab helps you achieve this.
Thank you, Shlomo. Yeah, I want to get a little more detailed in some of the components that we're using in the tooling with GitLab. It's a great vision that Shlomo and Arctiq are putting forth into the industry and really can go into the return on investment and benefit analysis that you do inside your organization. So GitLab is a product, it's a company, it's an open source application, and we leverage it to create this idea of GitOps for the infrastructure teams. And these are software development lifecycle best practices that developers have been using for years and years. This is DevOps as a single platform. But in the world of GitOps, that we see really three main components that you need and want to leverage in order to get this going. First, infrastructure as code, representing everything as code so we can manage it as a software asset. Creating these merge requests and these feature branches that Shlomo talked about. I'll get into more of what those are and what they look like. And then leveraging continuous integration, automatic reconciliation, continuous deployment capabilities to automate your environment. So in storing environmental config as code in Git. So we can store, and once you get into this mindset, you'll realize that almost everything you type on a keyboard is some sort of code. It's human language, it's web pages, it's documentation, it's runbooks, it's configuration files, environmental, declarative, templates, and YAML. It's at least the scripts you're already using in your automation. And so all these should be stored in a version control system like Git. And that's where GitLab really starts, is as a source code and version control tool. But being so much more than that now, we're able to, what we call in the industry, shift left to achieve this flow. And what that really means is creating these pipelines that go downstream, but pulling as much of that as reasonably possible into the field of vision of the person who's there writing the code and testing. So not everything in the infrastructure world can be tested fully before it goes, until it goes into some of these staging and pre-prod phases, because you're actually making real world changes to configurations. But there's a lot that can be done on the infrastructure side, just like in the developer side, such as security, testing, and tooling, pulling it into the field of vision of the person who's making the change so that they can fix whatever it is and fix the bugs that may be introduced right there in the merge request. And so GitLab as a tool consolidates a lot of what is in this DevOps ecosystem down into a single application. So one platform that does value stream analytics, source code management, um, agile project planning, security scans, release management, deployment and CI/CD tooling, monitoring, protection, all the way down the line. So there's only one tool to install in order to get these things done. And then we manage and call the direct code bases like Terraform or Ansible or Puppet or Chef, things like that, to actually make configuration changes. But it's one user interface that the entire organization can come together on, an unified data model that you can do analytics across the board. So we want to think outside the box. So GitOps in this style of sustainable deployment can be used on a lot of different aspects of infrastructure. You could, and it's actually, when I came to GitLab, my first request from a customer was to help them automate and use agile techniques to test vendor supplied DLLs on physical vending machines that ran Microsoft Windows OS. And so there was no source code involved at all. But what there was were testing scripts. There were the results of the testing output that could be committed back to the code repos and aligned as a release with the DLL that they received from a vendor, so that entire code package and the output of testing could be archived as a release, and that immutable artifact could be stored for support issues later down the line, that sort of thing. So really interesting use cases. You can affect cloud migrations with, and you'll see what I mean when I talk about runners and how these pipelines work. You could have GitLab deploy to a VMware, a Tanzu, an OpenShift, Red Hat environment, a legacy physical infrastructure that you have on premise. And then, especially if you're running something like Kubernetes in different environments, or you're making the code base changes that Shlomo was talking about, very quickly and easily, you could point GitLab to deploy the same application in a public cloud and affect cloud migrations with just sort of label changes and tags to the environmental variables that you have in GitLab, and fully deploy onto another cloud environment. Bringing DevOps into this entire tool chain and allowing you to not only provision, but also, as Shlomo said, deprovisioning, decommissioning, destroying in a Terraform world the infrastructure that you don't need once you see that it is being freed up and not used. So storing everything in Git allows these really interesting use cases of creation of environments, just like the deploying of applications and testing of all of these things, as well as decommissioning. Now, the agent of change control in an infrastructure world is in this world a merge request. And a merge request is the work stream, the branch off of the main project that you as a DevOps engineer would use to make the changes to your configurations, go through the testing, collaborate on those, and get the approval that these are valid and suitable for production. And so with a production configuration from a developer's point of view, this is the main feature branch, right? Or the main branch that represents production. You create a merge request, and it's here that you could use GitLab as a repository for your Terraform modules, for your Ansible calls, for your CLI scripts, right? You're making your changes and committing them to your feature branch. The CI pipelines run and they do all the testing necessary. And we even bring linting, syntax validation, dry run capabilities in different environments, security testing to this world of infrastructure provisioning. We can run the pipeline in a testing or lab environment. You see the results and the output right there in your feature branch. And you, as the DevOps developer of infrastructure of GitOps, can see the results, fix whatever's broken, automatically run through that CI pipeline. This is the inner loop of development as quickly as you can. And then in GitLab, we can have enforced peer review and approvals. So this is key to the collaboration, that it forces you to submit your change to a senior architect. You can have junior DevOps engineers submitting to you as a senior architect, and you review any changes before they're accepted and merged into the main production. And once those approvals, and it could be a security team, it could be a governance team, approves the change control board, someone who sits there approves the change. And once it's done, that merge is closed and pulled into main. So then the rest of CD pipelines can run towards staging and production. So this merge request is the tool that we use to pull visibility down from all these different testing systems into the field of view of the developer, the DevOps engineer who is running on it. You can see the pipelines that are running. This merge request here requires approval. Whoever's looking at this screen is actually an approver. They can click the blue button and begin the approval process. We see code quality scans. We see security scans detecting vulnerabilities, license compliance scans, Terraform output. And I see a typo in my variable here. So you can actually, if we're using Terraform, the Terraform outputs can come back into the pipeline, into the merge request, and you can click on them and see the output of Terraform right there, as well as any job, the raw output of any job that you run here. So a very deep integration with various tools in the environment to allow you to deploy and then decommission for sustainable reasons. Just some security ideas for you before you deploy into production, even not just application code, but even configuration changes can be security scanned. We can look for passwords. We can look for keys that might be leaking out into the world. We can look at license and compliance if you're using any tools that we detect that your organization doesn't want you to use from a licensing point of view. Somebody's trying to use something that's non-compliant. Full container scanning if you're building containers and using them to run your jobs. So a lot is possible here within the field of view of the DevOps engineer that you might not have thought about for Terraform modules, right? We can do security and scanning on everything that goes into production, not just the app. SAST, so static security analysis for configuration code. Notice that we should not be using public IP addresses. We could find passwords and secrets in the infrastructure code. S3 buckets with public read-write access. So these things are meaningful, and the built-in security and scanning in GitLab can detect a lot of critical issues before they get into production. And finally, required approval. So anything, as we used to say in the infrastructure space, as a total joke, nothing tests like production. Come to find out a decade later in the application software delivery space, no, that's actually what they do. And so you can run canary deployments, you can run A/B testing and actually test your code in production. Well, that may or may not be completely relevant to the infrastructure team who needs to be sure that their code is going to work the first time. So we can run in these various staged environments on our way to production, and we can have approvers along the way to have a vigorous, though agile, change control and approval process at every stage. So that's the value that GitLab brings to any language framework, any GitOps type tool. I see you coming online, Shlomo. Are there any questions?
I like the vigorous but agile. A lot of people think that governance isn't something that can be agile, but you just showed it one place to manage it all, one place to easily let the right people approve. I just want to touch on that because I've gone to so many very startup-y enterprises, but governance kind of falls the wayside because they don't see it as an agile possibility, but it entirely is. I just want to, I like the way you phrased, the way you said it. That was the only reason. It was to comment on your
Great.
comment.
Now that we've paused, are there any questions? I saw a couple of things come through in chat. Anything I should address? Yep. Okay. Hearing none, please interrupt me, Scott, if there's anything I need to do. So there's a lot of value here for a tool that governs this entire workflow and provides a single security framework around it, right? Not only for the developers, but also for the infrastructure teams. Now, automation reconciliation, automated deployment. There's a lot of tools in this space, and GitLab is not Terraform. GitLab is not Puppet or Chef. We're not scripts. We're the thing that calls, right? We are the platform and workflow that calls these tools to go do their job. And these reconciliation loops that can run in a couple of different methods or styles. Some of the industry in the next slide actually will talk about pull or push based deployments, but CICD is a methodology where you're really pushing out changes. You're doing some testing, you're building your own scripts, and you're making sure that the script execution runs correctly. And then you're calling out to some environment in order to deploy. And the pull methodology is more analogous to and applicable to Kubernetes environments and really declarative environments where if a change is detected, something on the end cluster will pull that new configuration in and apply it directly on the cluster. And sometimes there are security benefits for that as well, so that your end environment is always pulling, no one's anytime calling into that environment from the outside. So there's pluses and minuses for each. And generally what we've been talking about with pipeline tools is this push-based CI/CD workflow. Like, even though it's Terraform and it's a declarative model, we're using a CI/CD pipeline to execute Terraform and push into the world. The other way we also support within GitLab is a pull-based model where we actually install a reconciliation engine, the GitLab Kubernetes agent, out on a Kubernetes cluster, and we declare that whatever is in a certain file path should be deployed automatically to the cluster, right? And so this only really works in environments like Kubernetes where you're really defining the end state, and the reconciliation ability of Kubernetes itself will pull that. So let me just kind of quickly show you an environment that looks like that and show you what it looks like. Shlomo's already shown you kind of a CI/CD pipeline. So this is, again, everything in GitLab is expressed as code. So the GitLab CI, so the continuous integration pipeline, is very simple. You have various stages. This is the push method that Shlomo's already described, but it can be described as, it's all described as code. And then the GitLab agents, each of these is a Kubernetes cluster. I named one Kubernetes cluster called services, another one called Lab 1675. And inside services, there is a configuration of the GitLab agent. Here, I'm telling this agent, if you find any YAML underneath the services folder in the project, basically deploy it, right? Reconcile Kubernetes to this folder of declared YAML. The same thing is true on this cluster. We're going to reconcile it to everything under the folder Lab 1675. So what does the project actually look like? I have a folder, services, web server, and in here is a couple of sets of YAML, and I'm just kind of creating a web server with a namespace. So the point is, in this style, we have a GitLab agent that's calling back to GitLab. And so there's one security profile. That agent can run as any service account in the Kubernetes cluster. It can impersonate service accounts if you would like it to. So there's a ton of flexibility there, and it will reconcile the running state of the scope in which you declare it to edge inside Kubernetes to whatever's running in these folders. So the services folder, you could have web servers, you could have Kubernetes, policies that you're defining here. So a very rich capability of, again, we're not even running CI/CD. The agent is looking at this changes in the folder, and without any CI/CD pipelines at all, Kubernetes is automatically reconciling. So that capability exists. That's there within
So,
GitLab as
so
well.
Scott, just I wanted to touch on one piece here because I look at this as maintaining the experience of Kubernetes clusters and what runs in them,
Sure.
similar to what Anthos config management is. Would you
Mhm.
consider them to be synonymous?
Within the same realm of yes. Synonymous, is a hard word to agree to, but because we have both of these capabilities, something like Argo CD here on the right is also a very similar product. We actually use the same open source project as Argo CD in that Kubernetes agent. It's the same open source reconciliation engine that Argo CD uses there. Um, but then also the same connectivity, because we're connected to that Kubernetes cluster, the development team can use traditional CI/CD workflows because we've already made the connection, we've established it, to do standard CI/CD pushes of applications out there. So you can have the best of both worlds and leverage the security profile of that one Kubernetes agent running. And honestly, you might have more than one Kubernetes agent running to manage, the GitOps workflows versus an agent that's credentialed and has the service account access to only manage application deployments and not be able to change, anything outside certain namespaces. So very flexible configurations. Like it's too much to kind of get into, but everything is possible, I should say. And then, so if you're doing CI/CD, I want to introduce everyone to a concept in GitLab that's very important, and it's called the GitLab Runner. And essentially, the runner is that executor. Like when you issue a CI/CD, when you go through a CI/CD pipeline, where does it run? Is it running on the machine that GitLab is running on? No, don't do that. It should be running on machines or clusters wherever is close to the environment that you're going to be deploying to. So if you're deploying to Kubernetes, you would have a GitLab runner potentially doing CI/CD on the Kubernetes cluster. If you were deploying to GCP somewhere, GKE, you could have runners there. Runners can be almost anything and everything. This vendor solution I mentioned earlier, where we were deploying on vending machines on Windows OS, I was thinking that as a maturity for that customer, perhaps we could actually deploy a GitLab runner on the vending machine. Like that's a stretch goal for me to be able to do the testing in an automated way, literally on the vending machine. So these are just a simple Go compiled binary. We can run it everywhere and anywhere, and that flexibility really unlocks some value because, especially in a sustainable world, you could do something like provision your runners, and the runners are scalable. If you do a lot of changes and are doing a lot of CI/CD, the runners actually are one of the primary workloads of what's going on because they're the thing that are executing all the Maven jobs, all the compile jobs, all the everything jobs, these runners. And GitLab itself is simply storing the metadata. So you could deploy the runners on something like GKE Autopilot in a data center that is compliant in the sense of only uses carbon neutral footprint data centers, right? Which Google actually does allow you in Terraform to set that as a policy. Anything that gets provisioned is on a carbon neutral data center. And then as you deploy this runner, and this screenshot has 3 runners and 3 different namespaces deployed for 3 different use cases, but it's only a single pod. And what Autopilot will do is actually scale this down. It sees that this pod doesn't do a whole lot, and it will make it the cheapest, most efficient, scaled down node and pod resource it can. Now, when a real job comes on, this pod isn't not actually doing the job. It's going to spin up a new pod to actually go do the work. And so these child pods, if you will, actually go do the work. And when they're done, they deprovision. And so in a overnight or when there are no jobs going on, you literally have a single pod running in GKE there's nothing to manage, right? The SREs at Google do a fine job. They written a couple of books about managing this environment. And so you can have a very efficient runner farm that scales essentially to zero for almost free, because the free tier in GKE includes a regional cluster. So all these runners are ephemeral. You could have different runners running in different data centers on different architectures. And that's what I meant by affecting a cloud migration. You could imagine a world where I have a runner on my OpenShift or VMware Tanzu farm on premise, and I want to migrate to the cloud or to a different cloud. All I have to do is tell my pipeline to run to a new cloud environment, and the runner local to that cloud will execute that pipeline through a difference in a tag, basically a variable inside GitLab, and you've affected a cloud migration by deploying the application onto a new infrastructure. So very cool capability if you integrate with the cloud providers and creating these farms. So I mentioned CI/CD pipelines as code. You kind of looked at one of the screenshots there that had a lot of echoes in it, but it's important that everything is code. Like even the pipelines themselves are simply code that we manage inside GitLab. So when you're creating your pipelines, you're going through a merge request to make a feature change to the pipeline itself, and you're testing the pipeline. If you're making a change to cloud provider infrastructure, you're issuing a merge request, you're having these things reviewed, your changes reviewed before they go into production. And so I want to just make sure you see here that GitLab is actually a Terraform state store. If we, let's see, let me come out of that mode and go. Do I have it here? Yeah. Let's see. Where's one that I actually have some state in? Not that one, not that one. It was this one, I bet, if I click down into it. So let me just, for sake of time, we can be a Terraform module store. So if you have pre-written Terraform modules, you can store them in GitLab, and Terraform recognizes us as a module repository or registry. Container registry, so there you can have any containers that you build. GitLab is also a container registry. GitLab is also a package registry. So any language frameworks that you use that you're building packages and need to store those, GitLab is also a package registry. So you're beginning to see how much of this developer environment we're bringing in one application to bear. Let's see. And then the security framework is really interesting as well. So very quickly, I've got a corporation here, Sustainable Corp, and in it, I have a project called Governance. And then different teams might be associated with different subgroups called apps and DevOps. So the people who are managing DevOps don't have access to the applications, and the application teams don't have access to DevOps. And so already we're beginning to see I can store my Terraform modules in GitLab. I can store the output where Terraform state in GitLab itself. That kind of blew by in one of the CI/CD code. It was so simple to declare that we're the state that you almost don't notice we're doing it. And then we can have vigorous security about who can deploy in what environment. Let's see, is this the one where in GitOps, let me click on this project. I have the CI/CD pipeline. Yeah, so very similar to what Shlomo suggested. I actually created an independent pipeline myself, and absolutely, we can go through and have a destroy phase. And what this suggests is we can have jobs that are manually triggered. Shlomo, speaking directly to you, you can define an environment where only people who have the privilege allowed to deploy and are part of the destructor's environment can have the authority to click the button to destroy something, right? If you want to lock it down, You can do that inside GitLab. You could do things like if the commit branch is main, so it's the deployed branch, not just a feature branch, or maybe you want a feature branch, and some sort of a verify variable has been issued. So if I want to run a pipeline manually, I can put in some variables right here. And if I define the right variable, which is essentially matching a secret that's already pre-provisioned, then I have the ability to run the pipeline. So it's kind of like a password check before you're allowed to run the pipeline. And the security model is really interesting because way up here in Sustainable Corp, you can set these variables within GitLab so that, variables, so that the destroy secret is hidden up at a group level, and any kind of environmental secrets, Terraform or keys, things like that, are hidden up at a group level where the people running the pipelines have no visibility to whatsoever. But underneath the covers, they can match things and do some security validation. So really powerful way to manage the entire flow from a security and sustainability point of view.
I think your mode of operation will change based on your mode of maturity, or level of maturity. So if you're extremely mature, you generally don't want to be involved as part of the destroy. Your output and input values match the efficacy level you're looking for to tolerate the destroy. So it comes out. But in most cases, if people ask me where do I start, I always say the build environment. The build environment has no efficacy to be persisting. The reason being is once an artifact is built, the purpose is done. So people ask me, where do I start? To start with your build environment. If your build environment isn't dynamically being created and destroyed, you're making a very large mistake because they actually don't need to have a persistence at all once the artifact is successfully created. But again, I do think having a destroy permission or optional flag, just a toggle, would make a lot of sense for organizations that are building maturity, and I like the way you've presented it, Scott. But once you've hit what we call implicit approval, implicit approval is you met all my requirements, so my approval is given to you without me actually having to do so. You can go through this entire process and destroy where you want without having any responsibility delineation requirements, just because it's documented as implicitly given. This is very advanced, but again, you transition from I will manually say destroy to I don't have anything to do with that. I implicitly approve because the process is so effective. But you get there.
Yeah, and we can enforce that in permissions models. Like if you have permission to destroy something, there is an implicit approval that you have permission to go ahead and do it. And we can prevent the destruction of things. We can prevent the deployment of anything, right? You can prevent changes from getting to critical environments by protecting within Git. You can protect that branch actually within GitLab. Other Git tools can't do this. So within GitLab, you can protect the main branch so that not just anybody can merge changes into that. So these pipelines will not run unless you have permission to make the change and merge into the environment that you're doing. A lot of strategies for implementing it. This is just a pipeline just to show that we can capture logs and store them. We can issue performance reports before and after performance charts when you do some automatic deployment and capture the results and validation. Just secret detection, license compliance. I think we've talked about that. Capacity reporting, right? You can integrate these infrastructure-centric ideas and concepts into the pipelines and have them run automatically.
I do think even for the one that you just showed, there's also infrastructure as code artistry, where many of these types of functions can also occur, checking your security format, going through documentation, making sure documentation is updated. So even infrastructure as code has what we would call artistic steps that are around how well you're planning the infrastructure and validating it along the way. It follows the same process. It's embedded inside, and then it integrates very well within the Gitflow process.
Yeah, and I'll be honest. infrastructure teams have been creating these workflows and graphical workflows and things like this for a long time, but the software development teams kind of did it better and in a more automated way. So we can pull you along, and these things, if you don't, you can have a test in here. You know, if your README or your runbook or your whatever it is, your compliance chart or the certain output from testing isn't in a certain place, you know, while you're doing your initial commits to changes, these things will fail. And like you just won't be able to pass through the gate until you just do what you should be doing. And things like code linting, you know, and secrets detection, things like that. Once these processes are in place, this is how the DevOps culture is created, to give people this implicit permission to go forth and make changes, because there are so many guardrails we can put on the process of approval that are just inherited from the software development world.
So if you take it as a cycle of maturity, I generally state start soft, your gates, so visibility compliance should be 100%, meaning you can see everything and what happened and what the metrics are, but gating should be soft until the maturity is achieved within an organization, which is rare. So I generally see semi-soft gating until regulated environments, but otherwise it's just visibility needs to be 100% compliant so that you don't get to prod without knowing what you're putting in it. That's the most important piece, and I want to make that very clear, because DevOps pushes for the responsiveness of pipelines with regards to, you know, am I degrading or improving versus am I 100% compliant, it's a fallacy. It's not possible, because vulnerabilities change at all times. So don't aim for 100% compliance, aim for 100% visibility, and that visibility should let you know if you're degrading or improving. Improving, good job, it's a pat on the back, it's digital tacos. But if it's degrading, you're going to get slowed down. We're going to find out what you're doing wrong so that we can start getting you on the path of improvement, but not compliance 100%. It doesn't happen, is basically all I see in the field.
Good point. I think I've shown you some of the code and talked about it, but you know, it's just a little bit on how to structure your repos. You can create different cloud environments and begin to enforce locking on different subfolders within projects. And so you can create what we call a mono repo of lots of infrastructure as code capabilities. You can create templates of different pipelines that are reusable and composable as atomic units within your environment. You know, we've talked a lot about GCP and GKE and Terraform, but absolutely the same kind of approach is possible on, you know, AWS and VMs, and if you want to go Kubernetes and Helm charts and things like that, like anything is possible, and the techniques are applicable no matter what technologies you're trying to manage to a certain extent underneath the covers. So
I'll just add, just as you were saying templates, I did watch one of our most advanced clients have pipelines that provision pipelines, so that the standards that you were alluding to could become like a default onboarding process, but versus the team building it, they could pass values into a pipeline that then produces pipelines using those values.
dynamic pipelines.
Phenomenal. The reason being is teams could adopt governance and as you said, with agility, but onboarding was minutes. And I looked at it and the consistency of the delivery, consistency and conformance, and how the tooling also consolidated with the standards was astonishing to watch. A pipeline of values creating pipeline using them. It was amazing. I've never seen an organization do that before, but from their perspective, it was that they didn't want to have to onboard every team. Every team could self-provision, I guess, inheritance of pipelines.
Yeah. And, you know, pipelines can call pipelines can call pipelines that pre-exist in other projects. So you can have a templates project and any like that just never changes unless certain administrators allow it to change. And so if you provision a new project, It could be templated and already have all the code stubbed. So if you're doing a, Java Spring application, not only are the Spring components stubbed in, and it's a starter project that all the developer has to do is add their business logic, all of the pipeline code is stubbed in, and you don't even really see it. It just calls out to a master pipeline template that is the corporate standard way of doing things. And so, yeah, developers you don't have to expose them to all of this. If you have a vigorous sort of DevOps team that enables junior developers just to write business logic, then absolutely, GitLab and can do that for you. But if you don't, let me just mention GitLab Auto DevOps. If you don't specify any pipelines at all, and you're deploying onto a Kubernetes cluster, you don't have to specify any pipeline at all. You just hit build, and magically it will build your application and deploy it into the cluster automatically. So yeah, a lot of value. I'm hungry. I don't know about you, but all this brain work is making me a little munchy feeling for some cookies.
Mine are at a distance too.
Yeah. Is everybody enjoying their cookies? Did you get your cookies in chat?
Just about to ask the same thing, yeah. Sounds like Nicole and her crew are enjoying the cookies.
I'm glad.
That's one verification there.
Glad that the cookies made it. Sweet. So yeah, a lot of maturity can be established here. You can start from nothing and get going, but even if you're a mature organization, there's a lot we can talk about between GitLab and Arctiq and how we can help you build these sustainable pipelines that make good, efficient use of your infrastructure, but also are sustainable by you over time and able to be matured and iterated on in a standard way. So thank you all for joining us today.
Thank you very much. Thank you, Scott. It was well articulated, and there's a lot of catchphrases that you used today I'm going to use again.
Glad to hear it.
Amazing. So I'll just wrap it up. So I just want to say thanks so much to Shlomo and Scott for your presentations today and sharing obviously your vast technical knowledge as well as your time. And it's always a pleasure to spend time with all of you and of course our friends and partners over at GitLab. So thanks so much everyone for joining us. We're going to be following up today's session with a recording. So if you'd like to reach out anytime to talk with us about using infrastructure as code, GitOps and GitLab to maintain a better planet and pipeline, we would love to hear from you. Also a thanks to Evan Walker, Jen Bailey, and Jenny Reeb for all your help with today's presentation and behind the scenes as well. So I think that's just about it. It sounds like everyone's got a snack and leading into pre-dinner time, and we'll leave you guys with an extra half hour in your day, but we really appreciate your time and attending the session today. So thank you so much from Arctiq and GitLab.
Thanks, Scott. Appreciate it. Take care,
everybody.
Take care.